Everyone, my name is Pranav Alaski from STM College of Engineering and Technology, Dharwad, studying in Department of Electronics and Communication Engineering. Today, I am writing a C program to encrypt a given text using block transposition algorithm. Block transposition cipher or block transposition algorithm is a type of classical cipher where the positions of the characters in the plain text are shifted based on a certain permutation or key without changing the actual characters themselves. The fundamental idea: the encryption does not alter the characters but only changes their order in a systematic way, making the original message unreadable unless the correct key is shown. Working mechanism: the plain text is divided into blocks of fixed length. A key, usually a permutation of number, is used to determine the order of columns in each block. Characters are placed in a matrix row wise and then read out column wise according to the key to produce the cipher text. Key characteristics: the key size is equal to block size, which is equal to number of columns. If the length of plain text is not a multiple of key length, padding characters are added to complete the block. The padding characters may be X or underscore. Advantages: it is simple and easy to implement. It preserves the frequency of letters, making it ideal for educational and learning purposes. Disadvantages: it is vulnerable to frequency analysis if used alone. Security is limited by key size and pattern predictability. Decryption process: it is the reverse of encryption. Rearranged characters are placed back into a matrix according to the key's inverse. Read the row wise to recover the original plain text. Use cases: it is often used in combination with other ciphers in historical cryptography. It helps understand the basics of modern encryption technique. Now, coming to the code part. As we can see, this is the code to implement the block transposition algorithm in C language. Now let us see the algorithm for it. Input the plain text. Accept the plain text message from the user that needs to be encrypted. Choose the key. Define a key as a permutation of numbers indicating the new order of characters in each block. Example 2031 for a block size of 41. Determine the block size. Block size is the length of the key. Divide the plain text into blocks of this size. Pad the plain text if needed. If the plain text length is not divisible by block size, add extra characters, example X or underscore, to make it perfect multiple. Rearrange characters in each block. For each block, rearrange the characters according to order specified in the key. Combine all rearranged blocks. Join the rearranged blocks sequentially to form the final cipher text. Output the encrypted text. Display the encrypted text as a result. Now, as we can see the output, we have given a text to encrypt as SDMCT. So the final encrypted text is CMDS double underscore and TE. Now let me explain the output for this. As we have given input text as SDMCT, so the length is 6 and the block size is 4, so it is splitting into two blocks. The first block is SDMC and the second block is ENT. Coming to the block 1, which contains SDMC, using key flower bracket 2031, 2 is M, 0 is S, 3 is C and D is 1. Now coming to the block 2, which is ET, since only 2 characters left and block size is 4, it is printing them as it is or padded with spaces. Hence the second part is T, which is spaces before TE. The final output. Here we have, as we have given input as SDMCT, it is divided into two. Block 1 SDMC, which becomes CMDS, and block 2, which is ET, printed with spaces or handled separately, which is TE. Now coming to the simulation part, I have written the code for this. Here I have given a block size as a 4. Now let me run the output. So I am taking an example as hello. As we can see here, hello has a 5 characters. So the first 4 characters HELL, which is reversed here, and the remaining character, which is O. So to make it 4, another 3 characters are padded, such as underscore. So the final output will be LLEHO underscore 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 and 0. Conclusion part. The block transposition algorithm is simple yet powerful classical encryption technique that highlights the importance of data rearrangement in securing information by altering the position of characters based on a defined key. It provides the basic level of confidentiality without changing the content itself. Though not secure for modern day application when used alone, it serves as a foundational concept in cryptography, helping learners understand how permutation based cipher works. Implementing this algorithm in C programming enhances logical thinking, matrix manipulation skills, and provides practical exposure to the core principles of data encryption and decryption. Thank you.